Okay. So we have the different forms of the equations. We are going to first write down the standard form, vertex form, factor form, and then the shopping list of things that we can find from each of them. So what I want you to be able to do is go between the quadratic forms to shop for the parts. There's some that are easier. For instance, vertex form, what do you think that's good for? Find the vertex, right? All of them will allow us to see if it's opening up or down. So, you know, you could find everything you need, most of it out of standard form, then get over to factor form to find the last little bit of information. And the bits of information that we have are not unlimited. It's these 5 things. We could find the Y-intercept, X-intercept, or roots. That's synonymous. It's just another way of speaking about it. You can find, if it opens up or down, the axis of symmetry, which is a part of the vertex. These are the 5 things we got to find. It's not unlimited. We got 3 equations. We got 5 things we could find. That's it. So it may feel like, well, is there more? Is there more? Other than within this whole system, the only other thing we'll add in Unit 3 is the quadratic formula. So I would actually put that over here. The quadratic formula, you could use, instead of factored form, you could find your roots from the quadratic formula. We'll do that later. But for now, let's see. I'm going to ask that you memorize these standard vertex factored form and what goes along with each of them. On Friday, you'll have to share that information on the quiz, okay, which will be individual. All right. Tell your neighbor, what is standard form of the quadratic? What is the standard form of the quadratic? Can you remember it? It starts with A. Okay. All right. All right, and here's the thing. I haven't asked you to memorize it yet, right? These things that we're going over now, I didn't really ask you to do yet. We're just going in a little deeper to it in order to have these down really well. Who's pretty confident for standard form? Who can help me with that? Yeah? Oh, yeah, Layla. Good. Y is equal to ax squared plus bx plus c. Y can also be written in function notation, like so. Okay? That's our key standard form. That's our standard form. Okay. Now, standard form, we're going to list all the things that's useful for. It's useful to find 4 of the 5 things. 4 of the 5 things we could find with standard form. So let's go ahead and tell your neighbor, what is the one thing that's hard to find with standard form of these things? If you remember, 5 seconds, just real quick, which is the one that you can't find with standard form? Or it's harder? All right. Who feels confident? I'll take a volunteer for this if you got it. What's the one thing out of none that we can't find?
You can't find the X-intercept?
Yeah. X-intercepts, the roots. The roots we're going to use factored form to find. Okay. So we'll list the other things. Hold off listing exactly what we can do here. Let's get all the functions up here. Vertex form. I expect like 80% aren't going to have this quite memorized yet. But who knows it right off the bat? So I'm not going to ask you to ask your neighbor right now. Let's get it started. Angie, what's one part of it?
F of x equals a, and then parentheses h.
You know it's x?
X. Oh, that's it. X minus, and then in parentheses h.
Good.
And then to the second plus k.
Pretty good. Perfect. Perfect. Is that what you said as well? You thought that was standard form?
Yeah.
Okay. Standard form is always the ABC. I heard someone else remember it that way. ABC is standard. Okay, what do you think vertex form is helpful to find the vertex, which has the axis of symmetry in that piece of information. Lastly, factored form. We did this one fairly recently. That was 2 weeks ago, though. Who still has that in their working memory? Layla.
Y equals parentheses x plus h.
Okay.
Parentheses x plus j.
Okay. It's close. You know that it's two functions like this. The one thing I'll add to that is the a is out in front. It's actually going to be x minus for both of them. I want you to add that, x minus for both of them. And then, because we don't want to confuse our lettering from vertex form, where h and k, we're going to find out in a second, h and k are our vertex. We have to use different letters for these values in here, because they're not our vertex values. What was it? Yeah. Perfect. P. Q. Okay. So we'll define all these values, but essentially we have A, B, and C. We have H and K for the vertex. We got P and Q for the factor form. So those are just the differences for them. Okay. Now, of these 5 things, we already established that. What did standard form cover? Let's see. Y-intercept? What is the y-intercept equal to in standard form? C equals C. I know that on a graph, I'm at the y-intercept when I'm at 3, 2, 1, 0, when y is 0, right? Excuse me, when x is 0. Here's x is 3, 2, 1. When x is 0, I'm on the y-axis. So you plug in 0 here, this term's gone. Plug in 0 there, that term's gone. So the y-intercept is C. Easy to find. Okay. What's another thing we could find? Opens up or down, and we can find that for all of them. So actually, the things that work for all of them, this isn't that easy to find the y-intercept, nor is this. So I'll leave those ones blank. But yeah, A, positive, A, negative. So if A is positive, A is negative. You can find it at any of them. A is positive. What? It's in the future. Or A is negative. The minimum or the maximum is just based on, does it open up? There's a minimum. Does it open down? There's a maximum. It's just if it's at the top or it's at the bottom. That's all those words mean, and it means the same thing here. Okay. All right, so we basically said where our y-intercepts and opening up or down fit. And then what are the 2 other things from standard form? Axis of symmetry. Let's write that. So we have these for all 3. This one is the axis of symmetry. X is equal to? Who remembers this one? Yeah, no.
Is it x equals negative b over 2 times a?
It absolutely is. Good job. 2 times a, right? Okay. The vertex form, we can also find the axis of symmetry. But I'm actually going to hold this off. We can find the vertex and axis of symmetry. I just want you to kind of put those there. Get those ready to fill in. Okay? I just added these here too because we could find it in these as well. Okay? Now, if I know the axis of symmetry, here's my parabola like this. Axis of symmetry is right where? Is it over the side over here? Where's it going to be?
Middle.
Right in the middle. So if I'm here, it's going to be right in the middle. Where's the vertex going to be? Is it going to be in a different area? Is it going to be over here? Good. The axis of symmetry cuts the parabola right in half. So the vertex has to either be at the top on that line of symmetry or on the bottom on that line of symmetry. So if I know that the vertex is on the axis of symmetry, guess what? Guess what I know for the x value, the x and the y? For the x, I know that it's at negative b over 2a. Because it's on the axis of symmetry. Once you know that axis, hey, you know the vertex. You find this value for x. What do you do when you have one value and you want to find the y value? You have x. How do you find the y? What do you have to do? Plug it in. Yeah. So this is just going to be plugging it in. Plug it in. You plug in, you find your y. What do we plug into? Whatever the equation is, the function for that problem is, whatever it is. So I'm going to put here, watch. You plug it in, it's f of whatever that value was. All this means is you plug it in. That's function notation. That's the value we're plugging in. All right. All right. Who could question? Please. You got it?
So like you said that you plug it in since it's like f of negative b times over 2a.
Right.
So is x and y just the same thing?
Well, this is f of negative b over 2a. So what this is saying, essentially, if I have like x, remember f of x is just function notation for our y value, right? So essentially, whatever I have for x, I would plug it into my function. So it would be f of whatever I'm plugging in for x to find my y. So this is my x value. Let's say that we found out that x was 3. Then I would plug 3 in for x and find the y value for that x value. All this is saying is you have an x value, you plug it in, you find your y value. That's what this f of that function is. That's what it's saying. Essentially, let's see. If you had f of x is equal to 2x plus 1, remember, if I had f of 3, it's going to be 2 times 3 plus 1. Okay. The only difference is this is given as like a small like mini formula here, negative b over 2a. You're going to actually get a number for that. You get your number from that by finding your axis. Then you just plug it in, make a function of that, plug it in for x for the same function you're dealing with. Maybe in the example I'll show you that exact point. Axis of symmetry. X is equal to, who remembers that for vertex form? It's okay, we're revisiting this. We hit this once. We were focused on completing the square. The axis of symmetry in vertex form is equal to h. It's that easy. And then I know the vertex is h for x because that's the axis of symmetry. We already figured out that that's on the axis. What is then for my y value going to be? Okay. You got it in vertex form. You just have to compare it to the function here and see, well, what changed? What did I input for h to get whatever we have? Okay. So we'll do that. Let's see. That's all we can do for vertex. Factored, what's the one thing that we missed? We know if it opens up or down. What else? X-intercepts. And now X-intercepts, it could be 1, it could be 2, or 0. This is the AKA. You're going to be called the roots. Okay? The roots is just another term for it. We'll define that as we go a little bit more, slightly more. Okay. All right. At the top of your notes, I'd like for you to put a number between 1 and 10 that shows how comfortable you are at this moment, after going over this right now, how comfortable you are with quadratics. As in, the final goal is going to be to have them memorize and work with them. So just put a number, box it out. I want to be able to reference that number later. All right. All right. We're going to go and shop a little bit using this quad. This is our first example problem. F of x is equal to, let's go, x squared plus 6x plus 5. All right. First, label this. What form is this in? Standard. Let's label it. So we're in standard form. Oh. Why not? That's horrible. We're in standard form. So we look, what is on our shopping list of standard form? What's in our shopping list? What can we find?
Y-intercept.
Y-intercept. If you're in standard form, you're happy about this. The Y-intercept is where? Back. Okay, we're going to have to graph all these as well. People at home are like, what is he doing? What was that? All right, we're graphing this. So we're at 1, 2, 3, 4, 5, y-intercept. Y is equal to 5. What else can we find? Someone else. What else can we find?
It opens up or down.
Opens up or down? What do we say? What's our A value? 1. Let's label our values. A is equal to 1. Go ahead and do B and C. So since A is 1, it's positive. It opens up. That means it has a minimum. B is 6. C is 5. Okay. So we have 2 pieces of information. Let's see, what else can we find in this form? Yeah, we can find the axis of symmetry. I think actually, trying to get over to vertex form to have that really easy is going to take some extra steps we don't need to do. Let's see if we can do this. Let's go ahead and do it. Let's see. So x is equal to the axis of symmetry. X is equal to negative b over 2a. I want you to go ahead and find that on your own. This is b. This is a. Go ahead and plug that in. Find your axis. Where do we find a and b? We just labeled them. They're always whatever's in front of our variable in that constant. Negative 6. I see. So our axis is, there it is. I mean, is this step right here super tricky? If you had to do 100 of these problems, would that be bad? Well, that would be mean. But I mean, would you really worry about each individual one? I'm really confident. Each step you guys can do, we just have to work on a little bit and have it so you can see the whole thing. You get to see the whole thing. Okay. We know the axis of symmetry, so what do we know about the vertex? The x we know. The x, the vertex is on that axis of symmetry. So I want you to find the y and then check with your neighbor. Find the y, check with your neighbor. I'll put our axis up. Perfect. So let's look back to see what we had. To find the vertex u, plug in whatever you had for x to find your y. Where do we plug it in? Everything is about this function. That's what this problem is for. So let's go ahead and see about plugging that in for negative 3. What doesn't make sense? What doesn't? Negative 3 is the other. Got it. That's easy to forget. I do that twice a day. All right. You work this out. We get 9 minus 18 plus 5. We get negative 4. So when we plug in negative 3 for x, we get negative 4. You guys got negative 4?
Yes.
Perfect. Perfect. Okay, look, we have the y-intercept. Opens up or down. Axis of symmetry, I've dotted here. Our vertex is at negative 3, negative 4. It's right here. I know it's opening up. In fact, I also know this. That's one side. What do you think that other side's going to look like? The same, right? So I look, this is 3 away at this level. So I'm going to go 3 away on the other level. And we have the approximate shape. When you're doing these, I want you to do it by hand for the homework. And then at the very, very end, go to Desmos. Just make sure you got your roots right. You can put the graph in there. But don't cheat yourself. Like, try to do it on your own. Okay. We just need to know these points, our roots, our x-intercepts, and we're done. But you can't do it from this form. What do we have to change to? We got to get to factored. How did we go from here to here?
X method.
Perfect. X method. Make this line if it fits. X method. And go in the other direction. Foil. We spent a little bit of time just going between those two, and we learned that process. We'll review it right now too, as well. So let's see. Let's go over here. We got it here. This is actually really important. This is probably the key that throughout the day I've seen this is the issue. Okay. Remember that we're going to put our C value on the bottom, our B on the top. We're going to add to get us on the top, multiply to give us on the bottom. These two numbers that we're finding, these numbers are the factors. They are not our roots. They're just the factors, essentially going from a trinomial to two binomials. It's the opposite of FOIL. These are just factors, not roots. So I want you to put an arrow, I guess, to these. These are factors, not roots. This is like super key, guys. I want you to get that burnt into your head. Because the problem comes is when the next step, when we have it in this form and then we're looking to find our roots, some folks are like, well, what's the difference? Didn't we find the roots? We aren't finding the roots right now. We're just factoring this. So let's see. It's like a game. 5, 6. What multiplies to give me 5? 1 and 5, negative 5, negative 1. Which one of those add to give us 6? Good. So we know 5 is 5 and 1, negative 5, negative 1. That group adds to give us 6, so we know that is positive 5. That's positive 1. So here's the thing about it. This is equal to f of x, x plus 5, x plus 1. And then I have one last question for you. If you were going down the levels, here's y is equal to 5, 4, 3, 2. What is it going to be when I'm on the x-axis? 5, 4, 3, 2, 1, 0. When y is 0, you're on that x-axis. When y is 0. So watch. What I'm going to do here is to figure out where my x-intercepts are, I'm going to make this equal to 0. The reason I made it equal to 0 is because this is our y value, f of x function notation for y. I'm plugging in 0 for y. I'm seeing what x equals. Now, if I gave you this and I said, you will get 100% on the test if you can figure out what goes in here for x. That's an ugly 0. Let's make it better. Still ugly. But 2 times what gives you 0? 0. 100%, right? No doubt. The value in that for x has to be 0. No doubt, right? Okay. So essentially, that's what we're doing over here. If, when I multiply two things together, I get 0, right? This has to be 0, right? That has to be 0. Or that has to be 0 when we would compute it. You agree? Okay. So watch. If I don't know, say it's more complicated than this and I can't figure out what it is, then I'll just ask. Okay, x plus 5. When does that equal 0? When does this expression right here actually equal to 0? And I'll ask this one. X plus 1, when does that actually equal to 0? Minus 5, minus 5. When x is negative 5. Minus 1, when x is negative 1. Guess what we just found? The roots. That's how we're finding the roots. We're seeing the roots are when y is equal to 0. We know either this expression is 0, so we see when it equals 0. When x is negative 5, put a negative 5 there. What do you get? Put a negative 5?
0.
0. Put a negative 1?
0.
0. So that's how we make that work. That's how we find our x-intercept. So watch, I'll just put this here. That's -5. That's -1. Done. Okay. So I'm going to start you on the classwork. There's 1 or 2 parts of the classwork you won't be able to do quite yet. When we review tomorrow, we'll finish them up. So work as hard as you can on that with a partner. And we got like 20 minutes to work on this classwork. I wanted to give you time.